அது அம்மாவுக்கு மெசேஜ் அனுப்பிச்சு யூடியூப் லிங்கை கிளிக் பண்ண அது டிஸ்பிளே வருதுன்னு பார்க்கலாம். அம்மா அது வாட்ஸ்அப் ஓப்பன் பண்ணு. அந்த மெசேஜ் யூடியூப்னு இருக்கு பாரு.
இது பண்ணிட்டு வெளியே வந்துட்டு
சார் விமலேஷன் சார். சார் விமலேஷன் சார். Sir, Vimalation, sir, am I audible? Hello? Sir, Vimalation, sir. சார் சார் கேக்குதுங்களா? சார் கேக்குதுங்களா? சார் விமலரசன் சார்.
சார் கேக்குது சார். எஸ் ஆடிங்க சார்.
ஓகே சார். கெஸ்ட் வந்துட்டாங்களா?
எஸ் சார். ஜஸ்ட் ஆர்
வந்துட்டாங்களா சார்?
ஜாயின் பண்ணிட்டாங்க சார்.
சார் ஸ்டார்ட் Sir, start பண்ணலாமா?
எஸ் சார் ஸ்டார்ட் பண்ணலாம் சார்.
Let them join the remaining participants. Because one more session is there. So, good morning to all.
Good morning, sir.
Good morning. I am happy to welcome all the participants from various colleges, and also welcome dear students and my dear colleague. Special welcome to today's chief guest, this Vaishnavi Pandian, founder towards technology of this virtual seminar on applications of artificial intelligence in healthcare sectors. I am happy to say a few words about the department. The Department of Biomedical Engineering started in the year 2012. The institution is accredited by NAC, and also the department regularly organized various national and international level of a conference, seminar and workshop regularly. The department has received a fund from various funding agencies such as the Department of Biotechnology, Department of Science and Technology, Indian National Science Academy, Ministry of Earth Science, Atomic Energy Regulatory Board, Board of Research in Nuclear Science, Indian Council of Medical Research, TNSCST, Council of Scientific Industrial Research, etc., to conduct various activities as well as research program. The department vision is to promote, integrate research, education, and entrepreneurship at the forefront of biomedical engineering, to deliver high quality undergraduate education with modern pedagogical technique and state-of-art infrastructure facilities, to enrich the student with the needed skill set in order to meet the industrial need through constant interaction with the hospital and industry, to prepare the student for community service through free and candid learning environment that promote intellectual growth. Once again, I welcome to all the participants. I would like to request Professor Vimalarsan sir to introduce the chief guest and to take over the session. Thank you.
Yeah, thank you, sir. Am I audible?
Sir, Vimalarsan sir. Hello. Sir, Vimalarsan sir.
Sir, am I audible now?
Sir, yes sir. Please initiate.
Yeah. So, very good morning to one and all present here. I am very happy to be a part of this event. So, I'm here to introduce our guest, Ms. Vaishnavi Pandian. She is the founder at Towards Technology. She initially started her career as assistant professor in Banariamman Institute of Technology. So she had finished her master degree in Shanmuga Arts, Science, Technology and Research Academy, and her bachelor degree in PSG College of Technology. And she has experience in various fields like industrial automation, machine learning, deep learning, and she had a very good number of publications in reputed institute journals. And with I think today's session we will get some input from her session. Okay. I welcome Ms. Vaishnavi Pontian for the session.
Thank you, sir. Thank you for this wonderful introduction. Good morning, all.
Good morning, ma'am.
Good morning, ma'am.
Ma'am, you can present your screen if you have any presentations.
Yeah, sir. Sir, my screen is visible?
Yes, ma'am.
Yes, sir. Yeah, very good morning, all. Today I'm going to deliver a seminar on applications of artificial intelligence in healthcare sectors. Before getting to the topic, I just want to clarify a few things. Before getting to application of AI, we have to know what is meant by AI. Then what are the subfields available in AI? AI is nothing but it's artificial intelligence. What is meant by artificial intelligence? Simulation of human intelligence in machines that are programmed to think like humans and mimic their actions. Yeah, you all people know nowadays AI is in very hype because they just want to mimic like human beings. In whatever the field you are taken, you can apply artificial intelligence in their respective field. Because in every field, humans are performing very well. If we implement AI in those fields, they will perform more than the human beings in future. What they are trying to do, they just want to make the human being, whatever the activities be done, they just want to replicate. As a human, if I am an engineer, they want to replicate the engineer work. If I am a doctor, artificial intelligence want to replicate the doctor's work. Whatever the field you are taken, with the help of AI, we can replace the human in that field. What is the subfield of artificial intelligence? Machine learning and deep learning. These two terms we are heard regularly in our recent times. Let's see one by one. What is machine learning? Machine learning is nothing but it's a subfield of computer science. It's also, we are doing the same thing, make the computer to do the things like human being. For doing those things, what we are doing, we are giving data to the machine learning model and make the model to learn. After that, what we do, we are giving question alone to the machine learning model and ask the machine learning model to predict. Both machine learning, artificial intelligence, deep learning, all are doing the same thing, just replicate the human beings. Next, deep learning. What is meant by deep learning? Deep learning is very much similar to human beings, how humans think. We are thinking and doing some activities based on our neurons in the brain. The same concept will be taken and implemented in deep learning. In deep learning, they just create a mathematical model of your neurons. As a human, as a child, how we learn new things? Someone teach you, right? If I'm a child, means if my mother teach me like this is apple, this is orange, those things will be stored in my neurons. And after few days or few months, I will be remember those things. With nobody want to teach them. If I go to any shop and if I see apple, I can easily recognize this one as an apple. Those things are happened based on the neuron activities and some biological chemical reactions in our neuron, right? Those all actions and all activities will be converted into mathematical form in deep learning algorithm. Okay. Both machine learning and deep learning tries to do the same thing. Then what is the difference between machine learning and deep learning? If I take the machine learning, my application is I just want to classify the fruit, whether it will be tomato or cherry, right? Then the same thing, I want to do the same thing by using deep learning also. If I done the same task in machine learning, I have to extract the feature of the fruits and given those features as an input to the machine learning algorithm. What are the features? I want to describe the fruit. The fruit shape will be round, and for cherry, the fruit shape will be smaller round, and the leaf shape will be different from tomato and the cherry, right? Those features will be given to the machine learning algorithm. Based on the features, the machine learning will divide. This will be the tomato and this will be the cherry. Like that, my machine learning will divide. But if we go for the deep learning, we no need to extract the features. We just give the images of tomato and cherry. Deep learning itself divide. This will be tomato and this will be cherry. Like that, deep learning itself divide. The part of feature extraction will be eliminated in deep learning. Some people may think the feature extraction will not be the biggest step. It will be simple, like the radius will be higher for tomato and the radius will be smaller for cherry. Those things are very simple step. Then how it will be give various variation from machine learning to deep learning. If I want to classify the fruit means it will be small thing. But if I want to classify whether the scan report have tumor or not tumor, whether the scan report contain any fracture or not fracture. As a normal human being, I can't extract the important features from the scan report. Only the doctor can do, right? In those applications, we can't able to extract the feature from the scan report and then the application in machine learning. But in those areas, deep learning will help us. Because if I give the scan report alone, deep learning can be able to detect whether this scan report contains tumor or not, whether this scan report contains the fracture or not. Those things will be possible in deep learning. Only the main difference is feature extraction is must for machine learning, but in deep learning, feature extraction is done, but it's not will be done by human beings. Deep learning itself done feature extraction. Then next thing, why should we learn artificial intelligence? Nowadays, everyone or whatever the field you are going, whatever the application you are taken, everything will be replaced by AI. If I am an agriculture engineer, I want to do some project in my agri field. Whatever the expert suggests, go for artificial intelligence. Before artificial intelligence, everyone have a high on automation. After automation, nowadays everyone go for artificial intelligence. Whatever the field you may be biomedical engineer, you may be EC student or agriculture, aeronautics, whatever the field you are, you can done the job by artificial intelligence. Why should I learn this? Everyone going for artificial intelligence, then I also go for the artificial intelligence. It's not like that because while scrolling the Instagram or Facebook, any other social media, you may see this meme. The first victim of artificial intelligence is Tom. It may be funny and we will laugh and just scroll the memes, but we have in-depth knowledge on this because if artificial intelligence comes, it automatically replaces humans. So if you want to sustain in this world, we have to learn artificial intelligence. The technology is very important because you may be good in some soldering or you may be good in your field. This definitely this field will be replaced by artificial intelligence in future. So you have to learn that technology plus your field of knowledge. It will be very important. Next, how artificial intelligence will be applicable in medical sector. The first thing is disease identification. Whatever the disease you have, the main thing is doctor asks you to take some scan report. It may be MRI, CT, whatever. Based on the disease, the report may be vary, right? Then after taking the report, you have to consult the doctor whether I have the disease or not. Because by using the scan report as a human, as a normal human being, I can't able to identify whether I have tumor or not. And what is the stage of the tumor, whether it is in beginning state or it is in later stage. Those things it's not possible for me to identify. I have to go to the doctor and I have to take some doctor's suggestion, right? Nowadays, what happened means those things, if I have the scan report, I given to the artificial intelligence model. Those models can able to tell them you have the tumor or not. Those things is possible. By using the medical report, artificial intelligence can automatically detect the disease, whether the person is healthy or not healthy. Those things is possible by using artificial intelligence. Next, if the expert doctor is in foreign, for America or Africa, whatever the country they are in, but the patient will be in India, that doctor cannot able to travel due to some constraints. They can't able to travel, right? Nowadays, robot can do surgery and do some other activities like doctor with the help of some advanced technology. Many advanced technologies are involved for doing automatic surgery. One of the important technology in that is artificial intelligence. Okay, the robot can do the surgery by using animation, 3D, and virtual augmentation, reality. Those technologies are helpful. At the same time, AI is also play an important role for doing those surgery. Without the help of doctor, robot can do the surgery with the help of artificial intelligence. Next thing is, you all people see the doctor prescription. It will not be clear for you. The prescription we will given to the prescription to the medical. The medical employees will take the tablet and given to you. All right. Nowadays, the research going on read the prescription of doctor. If I scan the prescription, the artificial intelligence model can able to identify what are the diseases you have, what are the medicines you have, how many mg you have to take it. Those things will be done by help of artificial intelligence. Right. If I have the doctor will write this is in very short form, and your medical abnormalities in very short form and in their own clearable way, right? And after that they will write some tablets and some suggest some tablets. Nowadays those prescription will be read by artificial intelligence. If I give the prescription, the artificial intelligence can able to tell you what are the diseases you have, what are the abnormalities you have, what are the medicines you have to take. The AI can able to done those things. Next thing, nowadays what we are seeing, any human beings, whether they are educated or non-educated, they are coming from village side or very countryside, they are wearing some smart gadgets. It may be like smart shoes, smart watches, smart bag, smart t-shirt, smart goggle lens, everything they are wearable. What they do, your health parameters will be observed by using those things. Just imagine I am wearing one smartwatch. My smartwatch, what are the things my smartwatch will observe? It will read my BP level. It will read how much hours I walk in a day. Those things will be read by smartwatch. In future, by using those data, like my BP level, my regular BP level, and how much hours I walk in a day, those details will be collected. And by using those details, artificial intelligence may predict what are the diseases will have come for you in future. If I walk very low, for example, 100 steps per day, and my BP level will not be normal, and my heart rate also not be normal, by using those details, my artificial intelligence can help you. You may have risk of heart attack in upcoming 2 years. Those things will be, AI will recommend you. If those notification will get with, based on the notification, we will get some alert and we will change our lifestyle. For doing make our life healthier, AI will be very important. Next thing, for manufacturing drug. And nowadays, we know, suddenly new disease will come, like corona or some other new disease will come. Doctors are doing more research for identifying the drug for particular disease. What the main drawback of the disease is, if I take all the chemical components in real time and mix in the correct ratio and do the final product, after that I have to check the product in some rat or some other animals, right? It's a long-term process, and some process are constrained by government. Okay, with the help of machine learning, we will, by using mathematical equation, we will identify what will be the final product will be. If I take the chemical component 1 and chemical component 2 in the particular ratio, what will be the final product? Those things will be possible. So AI will help to identify the drug very easily. It will reduce the waste of time and waste of physical component, right? AI will help to identify the drug in a quicker way. These are the small applications that AI will be applicable in medical field. Today, what I'm going to do is how machine learning algorithm will be helpful for identifying the disease from medical image. Many applications are available. Now I am going to take one small application, how to detect the disease from medical images. Before I get into the medical image, you have to know what is meant by medical image. This is the process of creating visual representation of body, interior organs, and tissue functions. See, if I have my own body, okay, if I go for medical imaging, the medical imaging will give some clarity about how my body parts will be functioning. If I take the scan report of my hand, that scan report will help to tell whether any cholesterol sediment on my bone or not, any other fracture will apply on my bone or not. Those things will be easy to identify, right? Medical imaging, as a human being, we are not able to see our body functioning as a naturally, right? So we need some other help. That is the medical imaging. Medical imaging will try to know how our body function will be. Next, why medical imaging is very important. In older days, before the evolution of medical field, artificial intelligence, those things, in older days, if I have any boils in my hand, what I do, I have to go to the doctor. The doctor can't able to know whether it's a normal bump or it will be due to any fracture or those things. What they do, they literally cut our skin and will see whether any fracture are available in that, any internal bleeding available in those things or not. They, at that time, they don't have any medical imaging. So after the invention of medical imaging, they just scan our body and identify without getting any harmful cutting and surgery, those things. They will not, by using non-invasive method, they identify the function of our body. It will be very important, right? Because if I have a bump in my hand, but I don't have any fracture, it's like by small accident I will get the bump, but inside my hand there is no non-functionalities happens. If I leave it for 2 or 3 days, it will be reduced automatically, right? But I don't know whether it will be due to accident or whether internal bleeding or occurs or not. Those things I don't know, right? So what they do, they have to do some passive method, invasive method. So if I go for medical imaging, those things will be eliminated. By non-invasive method, we will identify whether it's a normal thing or abnormal thing. Next, medical imaging, where it will be used for. It will be used for diagnostic and non-diagnostic purpose. What is mean by diagnostic purpose? If I go for whether I have a headache, I have to go for the doctor. Doctor, I have to find whether the headache due to tumor or some other thing. For that purpose, for identifying whether any disease present in my body or not, if I taking medical image, this is called diagnostic. Non-diagnostic means you may see in some movies, what are the terrorists will do? They will transfer some drug to their body. They just in a capsule format, they will take the drugs in their body and they transfer those drugs from one country to another country. Right? In those applications, if I want to check the terrorist whether they have any drug in their body or not, if I do for that purpose medical imaging, this is called non-diagnostic. Okay, if I want to identify whether any disease present in my body or not, so I can go for diagnostic application. If I want to any criminal application will be happen in those area, I can go for non-diagnostic medical imaging. Next, what are the medical imaging available? CT scan, MRI, X-ray. These are the common terms you already heard. Apart from CT scan, MRI and X-ray, some other medical imaging are available. First thing is radiology. Radiology means they will pass some rays to our body. By using those rays, they will identify the function of our body. Under radiology, what are the medical images present are angiography, CT, computer tomography is nothing but CT scan, magnetic resonance imaging, MRI, ultrasound, X-ray. These things uses radiation. Next, microscopy. By using microscopy, we will identify some other diseases. What are the microscopic medical images available? Fluorescence, electron, gel, histopathology. Then photograph. Photograph is nothing but normal. Even by mobile also we will take and identify the disease. Right? What are the general things? Gross, endoscopic, retinal, dermatology. If I have any skin disease, I no need to go for any extraordinary method like CT scan, MRI scan. By the raw eye, I can identify whether it may be any itches or it may be hot bubbles. I can easily identify, right? For those applications, we can go for normal photograph. Then graph and drawing or comes under medical image. Apart from those images, some other medical images are available. Those are 3D and compound. Next, evaluation of medical images. In very later, in 1660s, only microscopic medical image alone possible. After 2017 and after 2020, at the age of 2020, many advanced techniques are available. In later days, what they do, medical image will be done by some other technicians, either lab technicians or some other person. They will take the medical image of your body and you have to collect the medical image from those persons and you have to search for a doctor. If I have a doubt of tumor, I have to search for tumor specialist. If I have any bone disease, I have to search for some orthopedic specialist, right? You have to search for a particular doctor and you have to take some suggestion. But nowadays, in the era of 2020, 2022, what we do, you have to, some labor will enough. You can go for some lab technician and collect the report of your, and by using automation technology, by using deep learning, machine learning, artificial intelligence, by just uploading your scan report, the machine learning model will tell what a kind of disease you have. It will be possible. You don't need to go for a doctor. If you have any abnormalities, any tumor or any other disease you have, you can go for a doctor for treatment. But if you don't have any disease, you can just analyze your body condition and you may just stay in your room. Okay. Why it is very important? Because nowadays everybody is busy and everything will be costly. If I am a normal human being, I am going for work regularly. If I don't have any disease, I have to wait for a doctor and take a consult. It's a long process, and the doctor fee also very high. But if the invention of artificial intelligence, machine learning, deep learning will eliminate those things. Next, what are the current challenges? Yeah, I already told. If I have the tumor or something, I take the medical report and go to the doctor. You have to identify the skilled person, right? The requirement of skilled person is very difficult because if I'm in any rural area, in my area, I don't have any specialist. In those things are very difficult for human beings. Next, early detection is very important. Even though they can able to identify the tumor, if the tumor is in starting stage, the person will not be able to identify. But machine learning, deep learning can be able to identify the tumor even if they are in very beginning stage. Next thing, accuracy. Yeah, I'm going for artificial intelligence, right? But I don't have full trust on AI also, right? If anyone designed a model with the accuracy of 80%, right? The model can have the chance of 20% fault. They may sometimes tell you if you have tumor, they will tell like you are healthy. If you are healthy, they will tell like you have a tumor. The accuracy is very important. For maintaining the accuracy in AI model is very difficult. You have to train the model in very good way. Next, no time. What no time means? Some models take very long time to predict the disease. Next, overcost. If I go for a doctor, it will be very high, right? Those things will be eliminated by applying artificial intelligence. In artificial intelligence, we have many fields like machine learning and deep learning. Now we will discuss about how machine learning will be used to identify the disease from medical images. Guys, are you okay with this flow?
Yes, ma'am.
Okay. Next thing, machine learning workflow. Before getting into the topic, I will say what are the steps present if I want to identify the disease from medical image. First step is problem statement. You have to be very clear what we gonna do. For example, I want to identify the tumor from CT scan. Okay, so you have to be very clear whatever the disease you have taken and from which image you have to take it. Because if I design, I want to identify the tumor from CT image. I design the model for that. If anyone give MRI report and identify the tumor means it is not possible. So you have to be very clear what type of disease you going to take and what type of image you have to be taken. You have to be very clear on that. Next thing, data collection. Whatever the thing, machine learning, deep learning or any other model, data is very important because machine learning and deep learning itself don't know whether it has tumor or non-tumor. By using the data and training, the machine learning and deep learning model will be able to identify. So data collection is important. You're going to train the model using the data. So those data will be very good. It should be very quality, right? Data collection is important. After that, data pre-processing. Even though you collect data in a very good way, the pre-processing is very much required because if we do some research, you cannot directly go to the hospital and collect the data. You may download the data from the internet. That is the one thing. All the data are not be true. So you have to be pre-processed. Then one more thing, even if you go to the hospital and collect the data, the scan report will be done by some machine. The machine will get old. Some other problem will be in the machine. So medical image contains some noise or some other things. So you have to do some pre-processing on those medical images. After that, feature extraction should be done. I already told if I go for machine learning, feature extraction is important. If I done the same process by deep learning, data collection, data pre-processing, after that we can directly go for modeling. No need for feature extraction manually. Here feature extraction is done. After feature extraction, we giving the result of feature extraction to the model. We have to design the model. After designing the model, we can go for validate the model. Once the model is designed, I am giving the tumor image until these images are tumor, and I am giving the normal images until these images are healthy. After that, the model will get trained, and it will give some mathematical equation, right? That mathematical equation is called machine learning model. I have to check whether this model will be correct or not. So I have to be validated. At the time of validation, the machine learning model will give good accuracy. Accuracy means number of correctly identified images. Okay. If it will be good, I can go for deployment. Why I go for deployment? Deployment means usually what researchers, some people do means they done all the processes. They will get accuracy of 99%, 99.5%, all the things they do, but they keep all the things in their laptop alone. It will not be useful for government, health sectors, and normal people. So you have to be make these things to the common people. The only way is you have to deploy. If I design a machine learning model to identify the tumor disease, right? Then I have to use this. By using this model, I'm going to develop one mobile app, and I have to implement those mobile app in the Play Store. Normal human being will automatically download the mobile app from the Play Store, and they will upload their scan report. The mobile app will tell whether they have disease or not. Like mobile app, we have some other deployment methods are available. Okay. This is the complete workflow of machine learning. First, you have to identify the problem statement. Next, you have to collect the data. The collected data will not be in clear format, so we can go for pre-processing. After pre-processing, can go for feature extraction. Then feature extraction, you design the model, then validate the model. If you are okay with the validation result, then deploy the model in real world. Let's see one by one very clearly. First thing is problem statement. Now, what problem statement I have taken is diagnosis of glaucoma from fundus image. Glaucoma is nothing but it's a kind of eye disease. Okay. Many medical images are available, right? Now I am taking fundus image. This is my problem statement. After identifying your problem, you can go for data collection. Before getting into the data collection, you have to know what is meant by data. It's nothing but facts and statistics collected together for reference and analysis. If you want to do some research, not only in the field of medical, if you want to do research in any field, finance, agri, aeronautics, whatever the field, you have to collect the data. That is very much important. Based on your application, the data availability will be in different form. What are the availability form of data? First thing is it will be in numeric form, it will be string form, it will be in audio format, it will be in video format, or it will be in image format. For example, I want to predict stock market of tomorrow for a particular company. If I do this research, in this research, the data will be in numeric format, right? For past 1 year, what will be the company profit? Those things are in number format, right? Next is string. If I want to create one chatbot, or if I take the same medical application, if I want to scan the prescription given by the doctor, by using those scanned prescription, I want to apply A. A will tell what is your age, what is your BP level, what is the tablet doctor will be suggest. Those things will be done by A, right? For those applications, the data will be in string format. Then audio format. In medical field, if a doctor take some ECG or some other audio related files, now those things will be in audio format. Based on my BP level, based on my heart beat. Okay, sorry, not BP level, heartbeat. Based on my heartbeat, my artificial intelligence can able to predict what are the diseases may be possible in my body. If I want to do those things by artificial intelligence, I have to train my model by using my heartbeat sound. In that application, the data will be in audio format. Then image, you already know. 1 minute. You already know. If I want to identify any tumor or fracture present in my body, at that time I can go for medical imaging. Next thing, video. If a mother is pregnant, they want to identify whether the movement of the baby will be in good or not, right? For that, they use some medical equipment and identify whether the baby movements are proper or not. If I want to do those things by artificial intelligence, in that case, the video will be the data. Clear? Data will be in any form based on your application. Next, data importance. Is just a small clip from one Tamil movie. What he told is, if you can able to handle the data properly, you can change the world, even in a better way or in a worst way, based on this. But if you can able to manage the data, you can make a revolution in the world, in the medical field, agri field, whatever the field you have taken. If you have the data and you can able to handle those data in a proper way, you can make definitely some revolution in those fields. Now, how I can collect the data? For collecting the data, two different methods are available. One is primary method and second one is secondary method. Let's see one by one. What is primary method? If your problem is unique, no previous research will be held on your problem statement. Collect your own data. For example, at the time of corona, you have to collect some data, right? At that time, you don't have any previous research on corona. It's a new disease. So you have to collect the data manually from hospital or some other thing, from lab technicians. By using some other method, you have to collect the data. If you directly collect the data, means that is called primary data collection. That's your own data set. You have to collect the data from 3 different hospitals and combine the data.
Excuse me, ma'am.
Yeah, ma'am.
Your presentation is not actually visible right now. Can you share once?
Okay. Okay, sir, now I share. Sir, whether it is not visible from starting onwards or now?
No. Just now it's gone.
Okay, sir.
Now it's visible.
Okay, sir.
Open.
Yeah, if your problem statement is unique and no previous research means, you can go for your own data collection method. Next thing, secondary data collection method. Secondary means if I want to do research in brain tumor. Already many lakhs and lakhs of people done research on brain tumor. They will collect brain tumor data from any hospital or by their own risk. By using the medical equipment, they will collect the data by using some government authorities and some things, right? After doing the research, they will publish the data in internet. You will just download the data from the internet and use those data for your research. If you done like this, this will be come under secondary method. If you directly go to the field and collect the data, and by using the doctors, with the help of doctor and some other expert, you will map. This will be the tumor image. This will be the non-tumor image. If you do like this, that will be comes under primary. Everything will be available in the by single take. You will do all the things. Means this will be come under secondary data collection. Next, for my problem statement, I have to find the glaucoma using the fundus image. Where I have to found those data. Dry, star, chase, HR. These are the standard data used for glaucoma, right? Whatever the application you are taken, there will be some standard data set. Those standard data set will be used by many researchers and verified by many researchers. You can confidently download those data because there will be no fault information present in those data. How will be identified whether these data are good and these data are bad? By using internet only, we can do those things. You have to refer many papers. If I want to do glaucoma, you have to refer previous research paper. How they use the data, whether they have to be collected manually or they have to use any standard data set. By using the previous research, you can identify what is the best data set for doing your research. For doing glaucoma detection, this will be the best data set. Once data will be collected. Next, what I do is I have to clean those data because whatever the data collected in the real world, it will be in dirty format. Okay. Some abnormalities will be present in those data. It will be noisy data, inconsistent, incomplete. What is meant by noisy? Because of the medical equipment, some noise present in those images. Okay. Then incomplete. They give the data in some image or some format. While taking the image in the phone, after that they will be processed, means some part of the image will be cut because they are not take the image of the medical image not properly, right? Those things will be happen. So you have to process the data. Why I have to process the data? If some irregularities present in the data, it's fine. I can go for the machine learning model. It's not like that. Even if you are good in modeling machine learning, you are a good engineer, you can model very superior model, but the data will not be good, means the output will also not be good. You have to be collect very best data and do very best pre-processing to get the superior result. So data pre-processing comes up. You have to convert your raw data into useful information, useful format or required format. For that purpose, you have to go for data pre-processing. Just I give you one small example. Everyone know how to put sambar. Like if I want to put sambar, means I have to collect the vegetables and do some pre-processing on those vegetables. If I take onion, I have to peel the onion and I have to cut and put it into the sambar. If I take tomato, I don't want to peel the skin of the tomato. I just directly cut and put into the sambar. If I take any other vegetable, based on the vegetable quality and based on the vegetable characteristics, I have to do some pre-process and put sambar. Right? Then only the sambar will be good. Even I put correct salt and correct some other ingredients. Even I put all the things. I have to cut the vegetables in a proper way. Then only the outcome will be good. Instead of this, I will take all the vegetables and put just like that and give correct water, salt and other ingredients and I will cook sambar. It will not be tasty, right? The same thing will be happen. I collect the data. I just give the collected data to the machine learning model and I define the ML model in a very good way. But the output will not be good. I have to do some pre-processing on the medical image. Not all the medical image have the same pre-processing technique. Based on the characteristics of the medical image, based on the irregularities present in the medical image, I have to do different pre-processing techniques like the vegetable. What are the pre-processing techniques available in medical images? First thing is image resizing. Because I have to collect the data from different hospital uses different medical equipment. Okay, so images are being in different sizes. So I have to convert all the images in the same size. Size means the height and width of the image. It should be in same. Then only processing, because I designed the machine learning model for the particular size of the image. For each image, I did not able to change my machine learning model, right? So I have to convert all the image into same size. Next thing, enhancement. Enhancement means the same thing. If you take any selfie, the image will not be clear. What do? You just change the brightness of your phone and take the image. At that time, your face will be looks good, right? The same thing. If I take the medical image, some information will not be clear. If I enhance the image, some little bit information also will be able to identify. Next, image conversion. Usually, if I go for MRI image, the image will be in different format. It will be in gray image or some other image. If I go for glaucoma image, that image, fundus image, in that application, the image will be in RGB format. RGB means red, green, blue, colored image. Different medical images are available and different images are in different format. Some images will be in RGB format and some images will be in binary format and some images will be in gray format. So you have to convert the image. Whatever the image you have to convert based on your requirement. If I have the RGB image, I can't directly process the RGB image to my machine learning model. I have to convert that RGB into gray. After that, I have to convert it. If I require, I have to convert in binary format and some other format. This is called image conversion. Next thing, edge detection. Why this edge detection come? Because if I take some medical image, the medical image will have the function of some area in my body, but I don't want the full area. I just want the tumor edge alone. By using those, extract those edges. After that, I will process whether the tumor in which stage, in starting stage or later stage, those things will be identified. Before going to that, I have to identify which is the tumor region by identifying those edges. Okay. Next thing, filtering. I already told, if I go for the medical machines, if the machine will be in older or something, some noises will defaultly present in the output of the medical image. So I have to eliminate those noise by using filtering technology. Next, region of interest. For example, I have my some rashes in my hand. Okay, I design AI model. If I take the picture, the AI will tell what kind of irregularity present in my skin. Okay, if I take the image, means I'm not directly take the rashes alone. I take my whole hand as an image, right? It is not necessary to process my whole hand to identify the type of skin disease. So what the machine learning will do, we have to do some pre-processing. Instead of taking the whole hand and process, I have to cut the particular area where my rashes will be present. I just cut those area and process what kind of rashes it will be, what kind of disease it will be, right? So no need to take the whole image. What is your area of interest? That thing will be separated. This is called region of interest. Next thing, masking. Masking means, take the same example. I have to identify the rashes. My whole hand image will be present. In that, I mask all the background, even table, my hand, and everything will be masked. Only the rashes will be highlighted. This is called masking. Everything will become black. Only the region of interest will be in the correct color. Next thing, segmentation. Segmentation means, if I take the X-ray of my hand, in that X-ray, not only bone alone will be visible. Instead of bone, background also visible, right? I have to segment bone alone. That is called segmentation. Extract bone image alone. These are the pre-processing available for medical imaging. Based on your application, you have to apply required pre-processing. My application is identification of glaucoma from the fundus image. This is fundus image. Okay. How I identify? If this is the fundus image. This is called cup, and the outer layer is called disc. You have to identify the distance between cup and the disc. If the distance will be more enough, then the image will be healthy. In case if the distance will be very less, then the person will be affected by glaucoma. Based on the cup and disc difference, the disease will be identified. Manually, this will be happen. Okay. If I go for automation, artificial intelligence or machine learning, deep learning help, I go for automation. And at that time, what to do? First, I collect the data from the standard data set like drive, shape. We already discussed, right? I collect the data. After that, what I do? This is my original image. I have to enhance the image. See, this is the normal image. After the enhancement, what will happen? The image quality will be very clear. The nerves going on the eye will be viewed very clearly. Okay, this is the purpose of enhancement. It will make the information in a better way. After enhancement, I will convert the image conversion. Okay, this will be in RGB format. I have to convert the image in the required format. Here, I am going for green channel image. Convert the RGB into green channel. After that, vessel segmentation will be done. This is my green channel image. From this image, vessel is nothing but the nerve going right. This is the vessel. I have to segment those vessel alone. See, vessel segmentation is done. If I done vessel segmentation directly from the RGB image, the level of accuracy will not be good. So I convert the image into green channel. After that, I done vessel segmentation. After vessel segmentation, I will identify the center part. See, by using the distance between up and this is, we identify the glaucoma, right? So I have to identify the center part. For identifying the center part, I have to do the pre-processing technique like enhanced image conversion, vessel segmentation. After that, I pinpoint the location of the cup. Okay. Next, my problem statement is I have to identify the disc. This is a whole image. I don't need to process the whole image. So what I do, I just cut the required part from the whole image. That is called region of interest. I just take the disc region alone. I am not directly disc region from the RGB image. I convert this RGB into green channel. After that, I done this ROI segmentation. Next, I am doing mask. Why I am doing mask? Because in ROI, I will not exactly get the disc shape alone. Only the smaller portion I will get. After that, I want to get disc portion alone. So I am going for mask. Only the disc portion will be in white, and apart from the vessel and some other images will be in black. Okay, this is called a masking. Whatever the particular part you want, that will be in white. Apart from all region will be black. After that, I convert the image into region of interest, right? I convert the original image into region of interest. After that, I done masking. Now I map this masking to the original image. This is my original image. In this original image, the mask, that disc part will be present in this area. I already done cup segmentation. Now I done mask. Mask of disc. Now what I am doing is I just merge both things. This is my mask and this is my cup region. Then I will identify the distance. It is not manually identified, right? If I put the scale and identify the difference, right, it's not possible. So you have to do feature extraction after pre-processing. In pre-processing, I identify disc region and the cup region. After done the pre-processing, I can go for feature extraction. Apart from this, I miss some filtering technique. In glaucoma image, filtering is not necessary. Okay, so it is not done pre-processing in the glaucoma image. So I take some other example. This is ultrasound image. Okay, this is the original ultrasound image. In this, many noise will be present. So I have to be apply some filter to convert this noisy image into some clean image. Okay. Before getting into the feature extraction, if you have good amount of data, then there will be no doubt. You can directly go for feature extraction. In case if you have minimal data, what we do, you have to do some augmentation technique. Why you are giving more concentration on data? Just imagine you are going to teach a child. You are teaching a child with apples 2 times. You give 2 kind of apple and teach the child. This will be apple and this will be orange. 2 apples you have and 2 oranges you have. If you teach the child, it will be remembered, right? After few days, you give the apple image to the child will identify. After a few days, it will chance of getting forget, right? In case if I give 100 apples to the child and 100 oranges to the child, it will be located in that child mind. It will be apple, it will be orange. If I teach the child more times and giving more number of data, it will be never identify the image as wrong. It will be definitely identify the image very good. Like the same way, machine learning and deep learning will give better result if you give more data. Then only the machine learning and deep learning will give better result. So if you collect data from the internet, if the data will be enough, means that's enough. Machine learning will do better. In case you don't have any sufficient number of data, at that time you can go for augmentation technique. What is meant by augmentation? I just take cat image for your easy understanding. This is one image. Original image I have, cat. I just flip this cat into left side and flip the cat to right side and zoom the cat and zoom out the cat and rotate the cat. Now I convert this single image into 6 various images. This is called augmentation. Then I collect 10 images. Okay, from the internet I collect 10 images. I done image augmentation on all those 10 images. Now what I get? I have get the 60 images, right? This is called data augmentation. In case if you don't have any sufficient number of data, you can go for augmentation technique. Different augmentation techniques are available. One is geometric method. This is what we discussed. Geometric method means just flipping, cropping, rotation, scaling, zoom in, zoom out. Those things are comes under geometric method. Then photometric method. Photometric method means color conversion, brightness, sharpness. Those things are comes under photometric. Then some algorithms are available to generate augmented images. Those things are comes under GAN. Now we collect the data, process the data. In case if you don't have sufficient number of data, you can do augmentation. After that, you can go for feature extraction. Because whatever the pre-processing is done is the image level only, right? Machine will not directly get the image as an input. It will be converted into some numerical, and those numerical values will be given to the machine learning model for input. Those things will be done by feature extraction. Different feature extraction techniques are available. I will share you the PPT at the end of the session. Just to go through the PPT. For statistical approaches, these are the available methods. For structural approaches, these will be the available feature extraction methods. For model-based, for graph-based, learning-based entropy methods. Different feature extraction methods are available. We can't directly tell. For this kind of image, this feature extraction will be good. Like that, we can't tell. So, how will we identify? By trial and error method only we identify. For example, I take the tumor image and then feature extraction by GLCA method. And I take feature extraction by Gabor decomposition method. The result of both feature extraction will be given to the same machine learning model and identify the result. From the result, the accuracy of one model will be good and other model will be smaller, right? Based on that, only we identify which feature extraction will be applicable for this kind of medical image. Okay, trial and error one method only helps you. Or otherwise, you can go for previous research and do some more readings. You can identify which method will be best. Clear? For this particular application, glaucoma application, in my pre-processing step, the output of the pre-processing will be cup identification and disc identification. At the end, I have to... Hello? At the end, I have to calculate the distance between disc and the cup. So it comes under statistical. The difference means some mathematical values I want. Mean value or covariance value, those things I need. Based on the value, the machine learning model will identify glaucoma present or not. So, for this particular application, I can go for statistical approaches. In statistical approaches, many algorithms are available. By trial and error method only, we identify which method will be suited for glaucoma detection. After feature extraction, what we do, we have to split the data. Some data for training and some data for testing. For example, I have 100 images. This is for example only. 100 images is not enough for training the ML model or AI model. More images will be required. For example, I am taking 100 images. If I have 100 images and 100 images are annotated images. Annotated means if I have image, this image have glaucoma or not. Those things I will be know. I have image and this will be glaucoma. I have another image, this will be normal image. Like that, I have image and the result of the image. I have 100 images. What I do is, I have to split the images into training and testing. 70 images for training and 30 images for testing. Why I have to split? Because for training the machine learning model, I give the image as well as label. Label is nothing but whether the image have glaucoma or not. Those things are labeled. I give image as input and label also as an input. Machine learning model will train and give the some prediction, mathematical equation. After that, I have to check whether the designed ML model will be correct or not. For testing those images, I have to use this test data. Remaining 30 images, right? Those 30 images alone given to the machine learning model and ask the model to predict whether it will be normal or glaucoma. The machine learning model will give some result. Those results will be compared with the actual result. Already you have right whether those images have glaucoma or not. Those results and machine learning results are compared. Based on the comparison, you will identify whether this machine learning model is trained in a good way or not. So I have to split the data into training and testing. After splitting the data, you have to train the model. Machine learning has two different ways. One is supervised learning, another one is supervised learning. If your data are annotated means if you know image and the output of the image, then you go for supervised learning. If you don't have those things, at that time you can go for unsupervised learning. Okay. Now we know we have the data and the data label. So I go for supervised learning. Different supervised learnings are available. SVM means support vector mission. KNN means K nearest neighbor. Naive, random forest, logistic regression. Some other supervised learning algorithms are available. You can choose any one and give the feature extracted output as the input to the machine learning model. Then the machine learning model will do some calculation inside and will give the ultimate ML model. Okay. Then model training. Training is a long-term process. If I give 10 images to the machine learning model will train within 1 minute. If I give 100 images to the machine learning model will train in 5 minutes. Okay. If I give lakhs of images to the machine learning model, it will take more time, more hours, more days, sometimes weeks also happen. Okay. Training will be a very long process. You already know if we give more data, then the model efficiency will be very good. If I give the more data, training time will be more. Okay. Once the model training will be completed, then you can go for model finalization. How we finalize the model? You have to verify whether the model will give better result or not. How I can verify? That is called model validation. Just see, this is called confession matrix. Using this matrix, we will validate any machine learning model. Okay. This is my confession matrix. Here, actual class. I already separate 30 images, right, for testing. Those 30 images will be given to the machine learning model, and my machine learning model will give some result. Okay. Those results comes under predicted class, and actual result comes under actual class. Positive means actually the given image has glaucoma. That is positive. If the given image does not contain any disease, it will be a healthy one. Then it will be negative. Okay. Then same thing. If the model predicts the given image has glaucoma means it will be positive. If the model predicts the given image has normal means it will be negative. Then we compared both actual and predictive classes. If actually the given image has glaucoma and my model also predicts the given image has glaucoma, then it will be called true positive. Okay. Then actually the image has glaucoma, but my model predicts it is a normal. Then it comes under false negative. Okay. Actually, my image does not have glaucoma, it will be normal. But my model predicts it has glaucoma. Then it comes under false positive. Similarly, the image has normal and my model also predicted it as a normal. Then it comes under true negative. Okay. True positive and true negative are correctly identified one. False positive and false negative are wrongly identified one. Okay. So using these 4 metrics, true positive, false positive, true negative, false negative. By using 4 matrices, we will identify some other metrics called accuracy, sensitivity, specificity, negative predictive value, precision, recall, F1 score. Many metrics are available. Based on the metrics, we will identify. I just take one metric, accuracy. Okay. In accuracy, I will calculate this formula and identify whether my accuracy is 99% means my model is very good. If my accuracy is 20% means my model is very poor. Okay. Based on the score of metrics, we will justify whether the model will be good or bad. Then one more thing, I take 30 images. In that 30 images, 15 images will be glaucoma. 15 images will be normal. Okay. Then true positive will be 15. But my model correctly predicted will be 13. And wrongly predicted true negative will be 12. Okay. Totally, my model predicted 13 plus 12, some 25 something, right? 13 plus 25 images will be correctly predicted by model. Remaining 5 images wrongly predicted by my model. That is called false negative and false positive. Now, I apply those values to this accuracy formula. After that, I will get some 95% or 92% I will get. By using those code, I will validate the model, whether it will be applicable or not. This validation is based on the user need only. For example, if I design the machine learning model for medical application, in those applications, accuracy will be very, very high. It should be 98 or 99% accuracy will be needed, compulsory. If I design the model for any commercial application means you may see some Snapchat or some other mobile app, right? If we scan your face, it will give some smiley or some hat or some other emojis in our face. If I design machine learning model for those purpose, at that time accuracy will not be that much important. I can go for 90% accuracy or 85% accuracy. If I go for medical application, accuracy will be very maximum. Next, model deployment. This is the very, very important stage, because in previous stage, I will get the accuracy of 99% for identifying glaucoma detection. Then it will not be useful, right? It will be only in my laptop. Even I am also not getting any profit. Person who are affected by glaucoma will not get any profit. Our country will not get any profit. You have to deploy those machine learning model in anything. You can deploy the model in mobile app, or you can create website, or you can create some hardware. How I deploy this model in mobile app? For example, I will create the mobile app. In that mobile app, user will log in. After that, mobile has camera, right? By using the camera, the person will directly capture the image of my eye, because it is RGB image only, right? The person will capture. After that, some pre-processing will held inside the mobile app. After pre-processing, feature extraction done. After that, machine learning model will deploy. The machine learning will tell you have glaucoma or not. Even normal person will do, right? They no need to go for a doctor or go for any lab, those things. Then apart from mobile app, what are the other ways? We can design a website. You have created a website and give a link. Person will log into the website and upload the scan report. The website will tell what is the status of your health. Next thing, hardware. Instead of creating mobile app and website, you can create a customized hardware for identifying those diseases, because not everything will be scanned by your mobile camera. Some disease detection requires some other type of medical imaging, right? In those areas, you can go for your required hardware based on the medical image. Based on the disease characteristics, you can go for customized hardware. After that, you can go for machine learning deployment. The hardware will easily identify the disease without the help of doctor and lab technician, etc. Then limitation. If you go for any AI model, machine learning or deep learning or some other thing, what are the limitations? Data will be the limitation. If I taken some rare tumor disease, in the world only 5 people have that kind of tumor, means data will be the problem, because machine learning, deep learning purely depend on data only. That is the problem. Next thing, if I go for the image, taken more images and training and further processing, my normal computer will not support, because memory needed is very high and processing speed should be very high. At that time, I can go for GPU, but GPU will be very costly. This is one kind of limitation. Then timing. If I can't go for more images, then the training time also very high. If I go for minimal computer, the model take more time to train. Next, to overcome this limitation, what we do? If I am a student, I can't afford GPU, but I want to do some research on brain tumor. What we do? Some online platforms are available. You can go for that platform. You are interested in deep learning, and you can have data and you have all other things, but your laptop will not cooperate with you. So the one and only solution is Google. Some other solutions are also available. I give you one solution: Google Collaboratory. Google Collaboratory is an online platform. By using your Gmail, account, you can access the Google Collaboratory. What the Google Collaboratory do? It will not use your CPU. It uses the Google CPU. So even if you have minimal specification in your laptop, you can process more number of data in Google Drive, in Google Collaboratory. Then, if you have low processing speed, the Google Colab run your program in cloud. It will access some other processing unit. So it is not your limitation. You can go for Google Collaborative for doing machine learning and deep learning models. Next, if I want to process the medical image processing using artificial intelligence or some other thing, you have to previously refer some papers. Why I have to refer previous papers? Why I am not directly start the research work? Because it will not be possible. You have to know what are the researchers going on. You have some other idea, but those ideas will already implemented, and those implementation will be available in those journals. So you have to use these medical image processing journals for starting your career. Okay. Next, these are the available books. If I want to do research in glaucoma, I can't directly do pre-processing, right? I have to know some previous knowledge on glaucoma. Based on what doctor will identify the glaucoma. Based on the cup and disc difference, doctor will identify the glaucoma, right? Like that, each disease have different characteristics. You have to know for disease, for a particular disease, what kind of processing will be applied. How the doctor will identify those diseases. Where the data will be identified. Those things will be available in those books. If you want to do medical image processing by using ML or DL, just refer these journals and these books. Now, my presentation is over. I just want to deliver those content. Which platform will be good for doing machine learning and deep learning research? And if you want to start a research, what are the things you have to refer? What are the journal articles you have to refer? What are the books available? Then best programming language. I didn't tell this. For doing medical image processing, most of us uses Python and some uses MATLAB. Both will be good. Then one more thing, MATLAB is a paid version. You have to pay the amount for software and you have to use. If you go for Python, many free softwares are available. Based on your need, you can choose the programming languages. Next, where to start? You have the idea. I want to do research on glaucoma. Then where to start? You have to collect the data first and process the data, and feature extraction has to done. After that, machine learning model. If I go for machine learning, many algorithms are available. Many techniques are available. Which technique will be chosen? Those things I want to clarify. Next, challenges in medical imaging. If I want to classify just a fruit, that will be very simple because the fruit will be very simple. Even as a human, anyone can classify. Like that, machine learning model also simply classify. But if I go for medical images, the medical image contain lot of unwanted information. You have to extract the useful information alone and process. So that's the challenging one. Next thing, emerging technology. If I want to automate identification of disease, you have to go for advanced technology like machine learning, deep learning, artificial intelligence. Apart from this, some other technologies are also available. Next, which one can I go for? Machine learning or deep learning? Based on your requirement, based on the availability of data, based on your time, based on your computer specification, you will choose machine learning or deep learning. Then, what are the best websites available for data collection? Those things are we discussed. Then one more thing, even machine learning or deep learning, data is very much important. If you don't have enough number of data, at that time what to do? I think I will answer all those questions. If you have any doubt, you may ask. I just finished my presentation.
Participants, the session is open for any queries. You can ask your queries to the speaker.
1 minute. I think, yeah. Hope you enjoy with this session. If you have any feedback, please give in comment section.
Ma'am, it was a wonderful and fine lecture. We have got lots of information from your lecture. Students and participants, if you have any queries, you can open up now and ask your questions and get clarified.
If you don't have any question, kindly give your feedback also.
Now, madam, yes, madam. Yes. Today,
Sir,
Yes, ma'am.
I think no questions there, sir.
Yeah, if there is no queries, let's wind up the session, ma'am.
Okay, sir. Okay, thank you, sir.
Okay, thanks. Yeah, participants, the next lecture session will be starting at 11:25. So it will be starting at 11:30 exactly. So let's have a small break for 10 minutes.
Thank you all. Thank you for this wonderful opportunity. Thank you all.
Thank you.
Thank you, ma'am.
Thank you very much. Nice informative session. Keep on organizing such session in future also. Thank you very much.
Yeah, thanks for your feedback, sir. Thank you. Yeah, participants, the next session will be starting at 11:30.
Sri, the கதவு சாத்து.
Yeah, welcome back, participants. So let us start the second session by Mr. Elliot Amal. So before starting the session, let me introduce Mr. Elliot Amal. So he completed his bachelor degree in engineering in Anna University, and he completed his master's in University of Bharathasan University. His in Masters of Business Administration. Then he completed his postgraduate programs in artificial intelligence and machine learning in Great Lakes Institute of Management and Texas School of Business. So he has various experience. He started his career as a software engineer in Span Technology Services Private Limited, and he held various positions like technical consultant and associate consultant in various companies like Ingersoll Rand India and freelancer.com. Then he got post as a senior lead engineer in Guardian Life. So with this brief introduction, I asked Mr. Elliot Amal to present his valuable lecture. So,
sure. Hello, everyone. Am I audible first?
Yeah, you are audible, sir. So I will close my presentation so that you can open.
Sure.
Yes, sir. You can present your screen now.
Okay, sir. Hello, everyone. Very good morning to all. So thank you for the wonderful introduction. So that is about me. And also like I'm currently working as a associate director for a multinational company on data science group. So under me, like I have 7 team members where we are looking at different research and analytics part of AI and ML. For example, like we are looking at how we can people call it as MLOps, and also I'm working on something called predicting how your model is behaving and customer analytics. So I've been looking at different divisions currently. So that is a gist about me. So for so for today's presentation, the topic you have already been looking at is like AI in healthcare. So healthcare is something very fundamental, and it's also like it's a need for everyone's life. So for example, if you get sick, you need to visit a doctor, you need to make an appointment to the doctor, they would prescribe some medicines, and it's basically there is a process around it. But if I take you to a journey probably like 20 years or 30 years back, there would not have been any such processes in place. So in upcoming slides, what I'm going to show is I'm going to say a few things in a very short about how AI was in past, present, and future, and now where is AI heading in healthcare, and what are the other things attached to healthcare with artificial intelligence. So I have a video to watch. So we'll quickly watch that and then we'll move towards it. Can you hear the audio?
No, sir. It is not audible. Yeah, video is fine, sir, but there's no audio on that.
Sorry, sir, you're not able to hear the audio?
Yes, sir. Video is fine,
Okay.
but there is no audio on that.
Okay, I'll try to get the audio and send it later. For now, let's look at the video alone, sir. Okay, so I hope you have watched the video. I understand there was no audio, but at least from the video, you would be able to understand what the video is all about. So they're looking at how to kind of bring in new processes, enhance customer experience for healthcare by digitalizing certain healthcare things and lot other things. Okay, so if we talk about past, present, and future in healthcare, so there was no process in place. As I said earlier, there's a workflow management. There's a management to govern things. When I say workflows, nothing but starting from how an a customer or a patient comes into your hospital till how he leaves your hospital. So everything, there's a process. If there's no process in place, then there will be a lot of chaos, and nothing will be very ordered. So that's what we were being lacking in the past. So there was no process in place, and as you know, like there was no digital era at that time. So it's all like everything has to be documented over a paper. The prescription, the medical records, everything was done over a paper. So which leads to a lot of there was no, as you can see, like there was no patient centric approach. When I say patient centric approach is nothing but the treatment or the experience is not focused or centric towards the patient, but it was rather towards how to cure a disease. That's what they were approaching in healthcare in past uh, zone. So there was like uh, no prevention of how we can stop spread of further disease. There was some lack of prevention over there, which led to a lot of security incidents. And when I say security incidents, is nothing but the patient's data safety and privacy was a concern. So that is also a concern why they didn't move from paper documentation to a digitalized documentation, which means that there was no technological advancements during those past time, which led to security incidents. So currently, where we are in, so currently where we are in healthcare. So currently, most of you know, like our healthcare system is getting day by day improved. Like a lot of technology advancements are coming into place, and a lot of regulations and compliances are coming into place. One such regulation is what they call it as the Health Insurance Portability and Accountability Act, simply termed as HIPAA. So they call it as HIPAA. So what this HIPAA tries to do is it tries to protect patients' privacy as much as possible. For example, uh, any healthcare information for a particular patient is very confidential. It shouldn't be leaked to outer world or should not be leaked to other person. So that's where like HIPAA is bringing in a lot of regulations, a lot of guidelines around that to make it how we can uh, bring a very patient-centric approach so that all the records are very protected and it's all having no hackers or no one has the access to get into your personal records. Next is like in the place of evaluating and diagnosing, it's becoming more and more common now. Say for example, you would have seen in a video where even after like post-COVID, we call it pre-COVID and a post-COVID era. So after post-COVID era, what happens is now patients need not to visit doctor. They can just make the doctor appointment based on the self-service through different app, through different portals, things like that. So that's what we coming to say that treating patients was never the same like past. So even a distance patient can be diagnosed, treated, and evaluated based on his needs. And now coming to the EMR, so we call it as EMR records, which is nothing but electronic medical records. EMR is nothing but health records which were in the paper form. So even a lot of AI advancements are coming into this EMR record. Say for in my upcoming slides, you have one of solution design where like you will be able to understand what is EMR records, where it is coming from certain appliances and how it is getting transferred to electronic medical records. So electronic medical records is nothing but you can consider as a central repository for storing all patients' medical records. So in this EMR, what happens is like they can access the records online, and also now slowly after the advancement in computer vision and in advancement in other OCR like object character recognition, ICR, things like that, even handwritten documentation are easy to extract, and then it can be sent into the electronic medical records. So before we were not able to extract any information from a piece of paper, but now with the help of advancement in AI, we are able to extract any critical information or any important information from a piece of paper, and then we can put it in a different repository like EMR, things like that. So that's where in the present. So future, what technology researchers or technology pioneers sees that AI is going to closely get with IoT devices. It's going to come with wearable technologies. So, for example, a patient who, like before even he understands the symptoms, there will be a track record going to a particular company where they will be keep tracking of his health care. Say, for example, like I am in my smartwatch, I'll be able to attach some sensors where it will try to tell me how's my heart rate or how's my heartbeat pumping up. So based on my different synthesis of the data, based on my different data, how the heart is pumping, I'll be able to understand whether there is some issue with the patient, or there's issue with the some other people or things like that. So IoT devices are coming up more than faster, and it's getting tied to AI technology, so that any data which has come from IoT smart devices like your wearables or your patient's wearables, something like that, it gets into a cloud environment. From the cloud, AI can easily access those data and create beautiful dashboards, see, understand what it is. Basically, we call it as a monitoring. So they were able to monitor what is the patient's data and things like that. And also we see a lot of advancement in the near future of robot assisting surgery. So it's like, say for example, a patient could be in a remote place uh, where he could have access only to a local doctor, but a well-renowned doctor or a provider could be in best parts of the world, so they cannot make an immediate travel. So that's where like 5G connectivity or advancements in robotics are coming into picture, where they are able to assist the patient through the robotic assist surgery. So let's spend some time about what are the growth of artificial intelligence in healthcare. So first growth factor is nothing but there's an increased AI presence in healthcare. So when it's compared to previous, past, present, future, and even in the like upcoming in 2030 or so, the AI presence is getting more and more bigger in this particular area. And second is, with the sophisticated machine learning models, we are now able to even predict whether a particular patient is having a cancer or not. So Google and a lot of big companies are getting into this particular area, where they are trying to understand whether that particular patient is going to develop a cancer or not. Even in some I'm sorry, even in some upcoming companies, they are even trying to predict the birth of a child, whether he would be having some diseases. So that's where like AI is coming into picture. Say, for example, if the parents of a child, let's say like someone is pregnant and they are a continuous smoker and they are into bad habits, then the AI is able to predict and warn them, saying that if you continue such habits, you will be prone to get your child affected based on these diagnosis, on these diseases, things like that. So that's where also AI is more coming into major disease areas. And finally, as I said, telehealth. So telehealth has already been started after COVID. Like people are more towards telehealth, like where people are trying to. Any questions? Okay. So in telehealth, where like lot of uh, even if you look at any small remote places, not like metropolitan cities, they have started this telehealth. How we can contact a doctor on a video conference, or understand what's important. Because after COVID, like never everybody stopped stepping out of the house, right? So that's where like telehealth is coming into a very fast pace. And like even you in my upcoming slides, you will see like what are the telehealth applications around this. So these are some growth of artificial intelligence in AI healthcare, where uh, technical pioneers or researchers are saying that AI in healthcare will be more. So this is on a market size of healthcare, where we are at 2021 or 2022, and how AI in healthcare is going to be get projected. If you look at the scale here, So there's a very vast difference. So in 2021 last year, the market size was just like around 11 billion USD dollar. But what researchers are predicting is, particularly this Prudence research company, what they are trying to predict is in 2025 it will be just 86.66, but in the upcoming in 2030 the market size and the growth of this is going to be hugely hit by around 187 billion dollars. So where we are at $15 billion market to a $38 billion market, and finally we are nearly into $200 billion market. So when you see the count, so upcoming generation like you guys, like you students, have more contribution towards AI in healthcare, because the market size is going to get huge and huge. So that's where like we need more and more subject matter experts, like people like you coming from biomedical engineering or other biopharma. We need more and more people who needs to understand what is the patient's uh, kind of patient's empathy, we'll say, like let's say patient empathy. For example, let's go back to the past itself. So during that there was no technical in advancements, but people were able to understand what the patient really needs. But now that's where like every research company are telling that we need lots of subject matter experts, where they'll be able to help a patient understand the behavior of the patient. So in analytics term we call it as patient journey. So we need to understand the journey of the patient, like starting from how they entered the hospital, how long they have been in the system. Let's say like some patient could be in the system for 5 to 10 years, and for example like in the 11th year they are admitted in the hospital. They should not give any drugs or any medicines just based on that particular year. So they have to understand the entire journey of that particular patient, which is good for him, what are the side effects we are getting into. So that's where like a lot of ML and AI algorithms are getting into picture. So here is certain AI healthcare applications. So first one, let's see about what is virtual assistants. So virtual assistants are nothing but, you can think it of a chatbot, but an advanced or sophisticated chatbot. So virtual assistants will try to book your appointments, schedule doctor appointments, will monitor your health status. It will try to give you your own medicines without even a doctor, you before even you consult a doctor. Which means that, let's say like in a crowded place, like let's say take an example like Chennai. So in a place like Chennai, crowded people, especially during COVID season or any other pandemic or any other epidemic kind of a era, where like you would have at least 100 of people visiting a doctor at a time. So virtual assistance tries to minimize that visit of the doctor. It tries to be a first hand of help before even you visit a doctor. It tries to say that whether I can be of help, I can solve your problem, whether I can schedule doctor appointments, whether I can monitor your health status, whether I can provide you some basic warnings or early warnings, something kind of a thing. So that's where like virtual assistants are coming into picture, and more virtual assistants will be developing in this particular healthcare. So when we speak about virtual assistants, what kind of technology stacks or what kind of specifications we are looking for virtual assistants is, someone should know what is AI, someone should know what is machine learning, someone should understand what is how to build a natural language processing. So all of them comes under a umbrella called natural language processing. Next is robot assisted surgery. So there are more and more applications coming into place where with the help of more 5G connectivity also coming in. So anyone in the remote era or in the remote village can be able to get the right treatment, even though if the doctor is sitting outside. So with the help of robot assisted surgery, every small pieces of the instruments or devices or any kind of specialized technology without the doctor, robot can do. But there will be a mid-level or a junior level doctor where they'll be assisting that particular robot, saying that instructing the robot how to do it. So for this particular robot assisted surgery, not anybody can get into this particular field. So it needs a certification, a certified doctor who's well trained in how to assist a robot. So there are some certification around that. So I would request you to just take a look about these different applications. So next coming is dosage error reduction. So because of more dosage or less dosage, we see vital signs in a patient where it leads to harmful uh, medication effects. So that's where like software will be in your dosage pumps, where it will try to detect whether the dosage is the right dosage for that particular patient or not. And finally, coming to wearables, as I said, the wearable IoT, sometimes they call it as a VOT, it tries to take a lot of data from sensors, actuators, softwares, which is then connected to a cloud, and from that analysis and other analytics of your health data gets in real time. So this is the important piece of it. So before, uh, even in the current world, uh, you cannot get any data real time. Say for example, if you take any x-rays or if you take any digital uh, images of something, you will not get it in real time. But what future is predicting is, even if you take any x-rays, your health records, everything will be in another 15 to 30 minutes. It will be in your EMR records, where it will be secured using some highly like blockchain technology, things like that. That's where like everything is going to come in. So if you take AI in a center, AI is going to be surrounded with IoT, blockchain, even meta, things like that. Everything is going to combine together, and that's what it's going to enhance a very patient centric experience. So this is on a very high level. What is AI in healthcare? So this is for a solution architecture. It will be really difficult for you to understand. That's why I've put up these 4 points. So let's look at this one. Let's understand that wearable devices are nothing but your smartwatches or patient wearables. Now they're giving even patient wearables in some places. So how that particular data from your wristwatch, how it goes and analyze, and with the help of AI, how it's going to get into different models, different algorithms, and finally how you're going to see it on a real-time UI. So that's the entire thing. So if you look at, let's say in the wearable devices, let's assume that I am wearing a smartwatch on this left-hand side column. So what happens? My data is constantly getting pushed into cloud. When I say cloud, cloud is nothing but a computer which is somewhere located, not on, which is not physically seen by me. So that is what I mean by cloud. So cloud is nothing but a computer which sits somewhere in US, in UK, or in any post of India region, where I cannot able to see. I cannot physically access it, but I can access it through sophisticated software. So what happens, from my wearable devices, data gets continuously feed. So when I feed this data continuously, since it's a very secured data, as I said earlier, patients' record are very secured. It should not be exposed to outer world. So that's where I have this two technology called gateway and firewall. So through gateway and firewall, my data gets sent into a control applications. When I say control application, it's nothing but from any IoT data, how I can convert it into a readable format. So that's where this control application will be. Say, for example, there will be different applications around the cloud. One such example is AWS IoT Core, AWS IoT Grasshopper, things like that. So what happens once the data is pushed to that particular IoT cloud, and that IoT will then take. Sorry. Okay. So from that, my data gets pushed into a data lake. So data lake is nothing but where lots of corporate data or lots of my important data are get stored for in it. So you'll be hearing more of data lake, data warehouse, data analytics when you talk about AI. So without this, AI cannot survive. Okay, it can survive, but it will be really difficult. It will be like a one hand without these things, I would say, one arm without these things. So that's where like data gets pushed to data lake, and then you have a data warehouse, and from there like you start to derive very business insights. If you understand the analytics of the patient, for example, if the patient is with your system, is with the hospital for 10 years, it will be able to understand the behavior of the patient, like what he likes to eat, whether he has some side effects, okay, and what is his usual sick season. Say for example, people get in India, people usually get cold. Example like me, I usually get cold during this particular season. So similar kind of an behavior is what we can sense through this particular data, since it's already connected to wearable devices. And finally, that particular data is can be shown to different set of persona people. Say for example, one set persona is like medical staff, they can view it, what that particular analytics is talking about, and another even the patient also have that interface, like a small app in your smartphones, where you will be able to understand your data in more readable and more meaningful way. So if I give the data just as it like let's say like heart pump this much, you will not be able to understand. But if I make it in a more readable, more presentable way, you'll be able to understand. So that's where like you will also get an app where you'll be able to understand what is happening, and also there will be an admin interface. So this is on a very high level. So if you take this particular cloud server, this is all on a cloud server. Okay, so what happens, this particular record, whatever comes from my IoT, it's not just getting into stored into data lake, but it's also constantly getting feed into a electronic health records, EHR or EMR. So electronic medical records or electronic health records. So it's all constantly storing into health records. So what happens, this particular one will be this particular health records is again related to compliance and governance. Say for example, if you're leaking any sensitive information, then the law or the government will sue that particular hospital or that particular providers, why they have released such information without concerned approval. So that's where like every technology with the help of AI are getting into picture, where some data from my smartwatch is getting transformed into cloud, doing some processing, and after which in a very readable format I'm getting it. So to share one particular incident, so during my last year or so, there was an hackathon. So what we created is like we had similar structure, like where we were able to get heart data from different IoT devices. So through that IoT devices, we were able to predict whether that particular heart data for a patient, whether you'll be able to get a heart stroke or not. We were able to predict a heart stroke or not. So this is on a very high level we were able to do, but rest of the architecture was similar to how we were. So we had IoT, then we had data like things like that. Then we brought in AI, ML algorithm, things like that. So this is on a very high level how wearable device solution architecture works. So now let's talk about who are the prominent players on the market. So as you can see, there are a lot of players. I just listed out top 6 players in healthcare. So first is Intel. So mostly everybody will know Intel because they are a pioneer or they are leader in processors, right? So surprisingly, they are also a leader in healthcare. They also have a division in healthcare. Philips, known for innovation, they are also related in healthcare. Microsoft, surprisingly, everybody is known for Windows, Excel, Microsoft Office, things like that. but they are also getting into a play where they also want to understand what is a patient's behavior. The reason why all these employers or big giant companies are coming to competition is because the market, the research, as I said earlier, the research in 2030 says that it's going to be nearly 200 billion market. So out of, let's say, 10 uh, corporates, each have think that they at least have to own a $10 billion market. So that's where like each focuses on each things. Say for example, Google focuses on predicting how to predict a cancer. So that there are lots of videos on Google. They are bringing in Google DeepMind, where they are able to predict cancer just based on the a scan of a pathology. They are able to take that pathology cells and they are able to detect whether that particular patient is prone to cancer, or the risk of cancer is more, or something like that. So that's where like most advancements are coming in. Another few more is that IBM, and finally is that Siemens Healthineers. So in the beginning video I've shown you, right? So that is a video of Siemens Healthineers. So these are not away from our reach. These are just about a reach. So eventually everyone will get all this sophisticated AI in healthcare with help of good subject matter experts. So that's where like a technology person cannot invade and do things like that. So we need lot of biomedical research people, we need biopharma, we need doctors, we need even nurses, any kind of healthcare professionals. We need all of them to come together and form an alliance, and then help AI to bring better patient experience. So this is just an case study. So this is about a company called Inspire. So Inspire is nothing. Is like it's an online health community. So they have life sciences companies. They have a two-part mission. First, it's like it connects with patients who are suffering from thousands of conditions, and second is that they connect with pharmaceutical companies. Okay, so there are two things out of it. So they are going, what Inspire trying to do is they are already have 2 million registered people. So they are going to form a community. They are going to recommend certain things for that particular community, and they are going to bring in some recommendation. They are going to bring in some sophisticated algorithms and look at how it is. So let's read about this one. So Inspire looked to build on its success and keep up with its own growth. It needed to overcome the scaling challenges posed by legacy on-premises infrastructure using managed solutions from AWS. So what they are trying to tell you is they are looking for a success, and it has to be scalable. So when they say scalable, it's nothing but for example, I started a hospital today. I have one patient visiting today, and all my infrastructure was just, I thought about only 100 patient will be visiting per month. But surprisingly, due to my better patient experience, due to word of mouth, and due to other reviews, things like that, my patient which I predicted to be 100 grown to 1 lakh. So in that case, that is what it's scalable. So when you have such scalable numbers, that's where you need to go from on-prem to cloud era. Okay, I know most of the things doesn't make sense to you, but if you just follow along, it will be simple. Okay, so there is a particular tool called Amazon SageMaker, where it will help developer and data scientists. They can build, train machine learning models quickly. So how they are using, it's like, as I said, Inspire, they have a portal app where they have a 2 million registered users, out of which they are going to recommend certain things. Like for example, they are going to say they're going to connect the patients, and they are going to give more personalized contents. For example, if someone has a cancer, and if they found that this particular patient is also having a same cancer, or this particular patient is having a stroke, and this particular patient is also having a stroke, if they find similarity between different patients, they are going to recommend same things to that particular patient. So that is what this particular case study talks about. Okay. So why Inspire uses AWS as a in healthcare is because they have improved user experience, and their click-through rate was increased by 281 percentage, 914 percentage, and average page views. So people who visited page views before AWS was very less, and people who visited page views after they move to AWS or cloud is 119 percentage, and also increased retention rate, which means that let's say like a patient staying for 5 years, after 6th year we have to think that whether he will stay or not. This is a problem, frequent problem in data science. We call it as churn or not churn. So churn prediction, lapse prediction, they'll say. So what we'll try to predict or understand is whether that particular patient, he has been with 5 years, whether he will go to a new network of hospitals or he will stay here. So that is what retention is all about. So, and they found that based on this uh, better user experience, better recommendation in place, understanding different patients and giving them the right uh, information, they were able to retain most of their patients in the same application itself. And also uh, Inspire also tries to help them provide different hospitals. Say for example, based on your condition or another condition, we can try to predict, saying that this particular hospital will be good for your particular health, this particular hospital will be good for your case. So similar, and also even in the drug discovery they are bringing in these kind of things. So for example, drug discovery stage is the very long stage. They'll say like most of the investments, most of the money goes into drug discovery, where like at least it will take 3 years to understand a drug. So people are investing more on these areas, where like how we can minimize those drug discovery, and how we can kind of bring in more AI in healthcare. So, and also the services we used is like Amazon SageMaker, which is for building AI and ML models. So Aurora is nothing but a database. Lambda is nothing but it's like a service where you run a bunch of codes on a runtime. And finally, Redshift is nothing but I spoke about data lake in one of my slides, right? So that's where this Redshift comes into picture. So it is a data lake, data warehouse, where you can query electronic records, or I mean patients' electronic records, and where you'll be able to understand what each data is all about. So this is all about AI in healthcare. So future is going to be more improved than we are in AI in healthcare. So already big companies have started to get into market. There are a lot of openings are coming in life sciences. There are a lot of openings are coming for freshers in pharmaceutical areas. So even in Chennai, lots of companies are getting into market to understand what is in healthcare. And also you would know like there are a lot of e-pharmacy company are also uh, growing up. So all of them are with the help of AI, ML, analytics. So all of them are tied together. You call it AI, you call it ML, you call it data science, analytics. All four are like siblings to each other. So with the help of all these things, and with the help of right subject matter experts, we are able to get into a future era where no one can predict what is going to be a patient. I just want to conclude saying my personal interest why I wanted to learn AI, because when I was started to learn AI, I understood that in particular Africa, patient who has to go to a doctor, it takes weeks for them to reach a doctor to understand whether they are even awake. So before even they reach, or before even they delay the cancer or whatever the diagnosis they have, it reaches to the next stage. So sadly they were not able to get the sophisticated. So that's where like um, there was a purpose for everyone to get into AI or ML to make the world a better place with the right set of tools and with right set of people. That's all I have for today's presentation. Thank you. Any questions, I'll be happy to answer.
Participants, if you have any queries, you can open up now. The session is open for queries.
And also, don't think that AI is something for technology person. It's never that way. So you are now getting into a AI world where previously people thought internet would not be in place. So that's how internet is important for every individual. AI is going to get that importance. So if you do not understand what is AI, then you will not have an upper hand in whatever you are getting into your biomedical pharma or things like that. So even a biomedical student, biomedical candidates, or let's say freshers in certain companies, what they are doing is they don't have any technical knowledge, they don't have any programming knowledge, but still they are able to understand the they're able to understand what it is, how to build a AI/ML model, what is a Python language, things like that, and they are building their own models. So they are doctors who are building AI. So this is how the culture is evolving. This is how uh, this particular field is evolving. So I would request everyone, if you are not already seen about AI in this particular, I would request everyone to start looking at this dimension, see how your subject matter expert can fit into AI, how you can bring in a better product for people within your reach, be it India, be it your state you're living, city, whatever region you're coming from. Any questions?
Good afternoon, sir. I'm audible.
Yes, hi, Madan.
Yes, sir. Sir, it was a nice informative session. But I have a question related to robotic assistive surgery. Can you, as a robotic person, I want to understand how AI influences the robot assisted surgery and your point of view in that for the
Yeah,
near future.
sure. Good question. Thanks for asking that question. So, as I said earlier in my slides, what doctors or providers they are predicting is, um, for example, let's assume I stay in a place A, but the doctors are staying in a place, let's assume R. So I'm just taking the annotation of alphabets A to Z so that you understand how much distance each alphabet is about. Say I'm staying at a place A, but there's a doctor who stays at a place called P. Let's say P. Okay, so much distance among them. So how we can bring in such efficient doctors into that particular place A is time consuming. It's cost also, like they have to spend a lot of money, and then they have to be, so that's where like robotics are coming into place, where they'll have a robotics attached in that same A place. They don't need sophisticated doctors, they don't need a subject matter experts at that place. With the help of 5G technology, how it's going to be coming up is that those particular providers who are staying at a particular place P, they will be able to guide and assist that robot, saying that how to even operate a surgery. So that is where like it's going to be becoming more and more. So even to get into that particular robotic assisted surgery, they have started some trainings around that. So slowly a lot of trainings will be coming in, where like people needs to get trained around that, and they have to understand how uh, robotic assisted surgeries works, because it's not given to anyone. They have a specific training. You have to do it for either 6 months or 1 year, and then you have to get into that field. And also, there is one thing I forgot is that automation also plays an equal role here. So you would have heard automation, like lot of automation you have heard. So that's where like robotic process automation they say. So as I said, if you take healthcare or hospital management, it is a workflow, it is a process starting from process A to Z. So there are a lot of process, like patient coming in till the patient exit. So all of them are manual and it's time consuming, be it entering the records of the patient who has come in, and be the visit of the doctor. All of them are time consuming. So that's also a area where like people are focusing how we can minimize all those manual works, and how we can bring in those automation in that workflow management. So going forward, it will not just be like subject matter experts, it will be also like how AI driven individuals are coming up. Thanks for that question, Madan.
Thank you, sir.
Any other questions? Thank you.
Okay, if there is no further queries, we can wind up the session. Mr. Elliot Amal, sir, this is really a wonderful session. You are very elaborate and informative. So thanks on behalf of Biomedical Engineering Department, KVCET.
My pleasure. Thank you.
Participants, the feedback link will be shared in the chat window. So kindly fill the feedback. And when filling that feedback, take some care in entering your name and your college names, so that that will reflect in your e-certificates. Okay, so take care of that.
Thanks, everyone. I wish everyone all the best, and best of luck for your future endeavors. Feel free to reach out to me. I'll be on LinkedIn. I'll be happy to assist you on any areas of AI, ML, data science. Thank you.
Sir, HOD sir. Shivkumar sir. Okay. So I'll take the privilege of concluding the session. I thank everyone for being part of this event. So I thank my management and my principal, my head of the department, for helping me to organize this event. So I think students would have got some useful insights, and they got some insights from this event. So it will be very useful. So we are planning on organizing more such events in the near future. Okay, thank you all. So thanks for your cooperation and participation. Thank you. So kindly fill the feedback form, and you will be provided with the e-certificates as soon as possible. Thank you all.
Sir, you can leave for 2 minutes, sir. Close பண்ணாதீங்க.
Okay, sir. Okay.